Hello class, this is Miss Fields here again, and today we're going to be using the phases of the moon simulation. Now, this is a really cool online resource for you to use because it's going to kind of show you the how and why of understanding the changing moon. So to begin, I'm going to show you some general settings of how this simulation works, and then I'm going to kind of model a learning goal and how I kind of expect you to think through the process of using the simulation to answer questions and learn about how to use scientific terminology and map the phases of the moon. So to begin, we'll start with this side of the demo screen. Now, I think it's very important for you guys to take notice of these two options. These are really cool resources because it shows you perspective of what you're seeing. The show flag, which you can see is on the moon right now, is showing you where you're seeing light reflected on the moon. Show view area kind of gives you perspective of where you're standing on the Earth and when you're looking at the moon, what you're seeing. And moving to this right screen, this is what you're going to be seeing from Earth. So imagine yourself standing on top of the Earth and looking at the moon in the night sky. This is what you'll be seeing. This screen on the left side gives you a perspective of what you would be seeing from space. But we're going to be focusing mostly on what you'll be seeing from Earth today. As you can see, below the image of what you're seeing in the night sky is also the scientific term for what you're seeing. And while you do your independent practice, you're going to be using this terminology and kind of looking for patterns in how and why are we using the word gibbous, what does waxing mean, etc. Another important feature that I want you guys to take notice of is the pause, fast forward, and kind of redo button. If you press this play button, not the pause button, excuse me, it's going to kind of show you how the moon orbits in respect to the Earth, and then also what you're going to be seeing from Earth. As you can see, the moon is rotating counterclockwise. But another important feature to look into is that the days, hours, and minutes also affect how fast that the moon is orbiting around Earth and also what you're seeing. So when we begin answering questions or reflecting about the cycle of the moon phases, specifically how long and what we're seeing over the course of each day, you can use this as a resource to tell you what part of the cycle that you're in. For example, 22 days and 18 hours, you're going to be towards the end of the moon phase. That is, it's getting smaller. And when you get to a new moon, it starts the cycle over. As you can see, it's 29 days. And then it goes back to 0 days. So for the purposes of my learning goal today, I'm going to kind of model for you what I would expect if your learning goal was describe what you see as the moon orbits around the Earth. So what I would begin by doing is making sure that I have my show flag and my show view area. And then I would be thinking in my head, okay, so we're going to be looking into how the moon is changing over the course of what this said was 29 days. If I use this tool to see that it rotates, or it not rotates, it orbits around the Earth. And then I would say, okay, I'm going to begin with 0 days, and then I'm going to slowly orbit it around the Earth and see what's changing. So as it orbits, I see, okay, in about the first week, I'm seeing that the amount of light being reflected from the sun onto the moon and to Earth, what we're seeing, the moon's getting bigger. So in that first week, the moon is getting bigger, and I could write that down in my science journal. It also appears that light begins to be reflected from the moon on the right side. So we'll see how that plays into effect as the moon gets bigger. I continue orbiting the moon around our Earth, and I can see it's still getting bigger, and it's kind of going from right to left. Next, I could write down in my online science journal, okay, so when the moon is directly in line with the Earth and the sun, it's at its biggest. It's a complete circle. And I would write those details down in my science journal as well. Also noting that it's called a full moon. And it's 2 weeks into the month, which kind of indicates that, okay, we're halfway through the moon phase cycle. As I rotate my moon more, I see, oh, it's getting smaller. So as we're on the second half of our moon phase, rather than getting bigger from right to left, it's getting smaller from right to left, or the amount of light is getting, or there's less light being reflected. So as I rotate, or as I orbit my moon around the Earth more, I'm seeing that it's getting smaller. And I could write that in my science journal as well, or illustrate it. I could also note that, okay, maybe this word waning means getting smaller because the moon is getting smaller. I orbit it a little bit more, and I see, oh, we're kind of towards the end of our moon cycle phase, and it continues to wane, which I can infer means get smaller, and we're at 25 days. Let me continue to orbit my moon. It's a little sliver now, so that means it's almost at its smallest, and we're at 27 days. So we know our moon phase cycle is about 30 days. So we can note that our last moon phase before it starts again is a waning crescent. So we can use these observations to think about what's a crescent and what does waning mean? Last, we can note that it takes about 29 days for the moon to orbit entirely around the Earth. And then we can also look at all of our observations too. We can see that the moon reflects light from right to left as it orbits in the first part of its cycle. And then, once it gets halfway to the full moon, it begins to get smaller from right to left. As I said before, both sides of this simulation tell you a lot of information. This shows you the perspective of an astronomer or an astronaut floating in space, and this shows you what you would be seeing from Earth. And also, this shows you what part of the moon phase cycle we're in according to the number of days. Now, I want you guys to independently begin to use this simulation to answer your own learning goals, which is, note how the moon orbits around the Earth. Specifically, what is the relationship between the moon's position and how much light it reflects from the sun? And then also, use scientific terminology to classify and characterize moon phases. So we kind of want to look into, ultimately, how the moon orbiting around the Earth is a predictable cycle, and we can see that by making observations of the changes they have in the night sky over the course of a single month. Now go on and begin to use the simulation yourself.